All right, let's take a look at this. Chapter number 8, multiplying and factoring polynomials. Right, so classify the given polynomial as a monomial. If you guys remember, mono prefix means 1. So polynomials means many terms, but each of these are classified as, well, we can classify it as monomial. Binomial means 2. Tri means 3. And identify the degree of the polynomial. So if we think about degree just means the highest exponent. Highest exponent. All right, and classifying by the degree, let's see. First degree would be linear. Second degree, this is what we learned about in chapter 9, quadratic. Third degree is cubic. And then fourth degree or more, we just say, fourth degree. If it was fifth degree, we say fifth degree and so forth. All right, so let's try to see letter A. We have 3x squared y squared plus 2x squared minus 4x squared. So here, clearly, our highest exponent is going to be 2, right? So we say degree of 2. So we say it's a quadratic. And then how many terms do we have? Well, we have 1, 2, and 3. Remember terms? Terms are separated by addition or subtraction. Terms are separated by addition or subtraction. So yeah, quadratic trinomial. All right, letter B. So identifying the highest exponent, that'll be fourth. So we say it's a fourth degree. And then here, there's no plus or minus here. It's all multiplication. So this is all just one term. All of that is considered one term. If you guys are thinking of maybe factors are separated by multiplication. So there would be 1, 2, 3, 4. 4 separate factors. But here, there's just one term. So fourth degree monomial. All right, next page. Let's see. We want to go ahead and write the polynomial in standard form and identify the leading coefficient. So just like we wrote our quadratics in standard form, we can do the same thing with polynomials, right? So standard form, this just means to write terms from highest exponent to lowest exponent. Highest exponent to lowest exponent, right? So this would be our first term, negative 3x squared. This would be our second term, negative 2x or minus 2x. And then plus 10 finally. So plus 10. I don't know why my camera keeps on going out of focus. All right, next it says to identify the leading coefficient. So leading coefficient. If you remember coefficient just means, well, the number in front of the variable. So that tells us that the leading coefficient is just, well, the number in front of the variable of the leading term. This is considered our leading term. So let's just make a note. Leading term. Right, negative 3x squared is our leading term. So that tells us our leading coefficient is just negative 3. All right, so writing this in standard form, that'll be x to the fourth minus 5x squared plus 7x and plus 15. All right, maybe I should have paused the video. Ideally, while you guys are doing this, please pause in between to try to do these by your guys' selves. Just, I guess, watching this video straight and then literally just copying my work probably doesn't do you any good for, I shouldn't say probably, it definitely doesn't do you any good for the final. So please at least try to do some of these problems by yourself once I explain the first one. All right, so adding these terms together, right? We're not multiplying, we are adding. Even if the directions didn't say add, we know that there's an addition in here, right? Addition in between here tells us that, well, we try to combine like terms. So let's see. This would be a like term because they have the same variable and the same exponent. So 6 of something plus 1 of something, that'll give me 7 of those things. And those things are x to the 5th power. All right, next. Maybe I see some students like they draw different shapes around like terms. I think that's a great idea. Let's see, 5x squared. There's no other like terms we can combine it with. So we just write that as so. Next, we can combine this minus x and this 8x. Negative 1 plus 8, that gives me 7 of those things, or plus 7x. And then lastly, combining my 10 and my negative 3, that gives me positive 7. Well, that's a lot of 7s. All right, 7x to the 5th plus 5x squared plus 7x plus 7. Final answer. All right, so please at least try to pause the video. Try to do number 16 by your guys' selves, please. All right, so number 16. Now we have subtraction though. So if you guys remember, hopefully you guys remember this, we have to sort of distribute. We can think of distributing this negative 1. So we have to multiply all of these by negative 1. That just means we flip the sign of each of those. That becomes minus m to the 5th minus 7m cubed plus 4. And then we just bring these down, right? Technically, we don't need that parentheses anymore. Minus m to the 3rd. All right, so same thing here. Now we just combine like terms. Now we just 5m to the 5th. We can combine that with that. Right, 5 of something minus 1 of those things gives me 4m to the 5th. Next, we have negative m cubed minus 7m cubed. So negative 1 minus 7, that gives me negative 8. Negative 8m cubed. And then lastly, let's see, where were we at? Oh, we just have this 4 left. Just the positive 4. So I used all my terms. And yeah, plus 4, and that'd be my final answer. All right, question number 17. We have 4 multiplied by 3x plus 2. All right, so you guys know distributive property. Now we need to sort of think about our exponent rules, right? 4x times 3x. Well, technically that's a 1. Technically that's a 1. So 3 times 4 is 12. But I technically said that those are exponents of 1 because we add those together when we multiply, right? Same base, we put that base and then add those exponents together. 1 plus 1 gives us 2, 12x squared. Why does it keep on going out of focus? All right, and then lastly, 4x times 2. Well, 4 times 2 is 8, and then we still needed x. So plus 8x. All right, number 18. A little bit different here, but it's the same line of thinking, except we need to do it twice. So hopefully you guys remember double distributive or double distribution. Double distribution, right? We distribute once, x times x, and x times negative 1. And then we distribute twice, negative 5 times x, negative 5 times negative 1. So x times x, using our exponent rules, that'll be x squared. X times negative 1 gives us minus x. Negative 5 times x gives us minus 5x. And then negative 5 times negative 1 is positive 5. All right, so we can combine these middle two terms because they're like terms. So we get x squared. Combining these gives us negative 6x. And then plus 5. All right, let's see. Question number 19. So please try to go ahead and pause the video and try to do 19 and 20 by yourselves, please. 19 and 20. Actually, try to do 19 through 23, actually. 19 to 23, we should be able to do by ourselves given those problems that I just did. All right, so ideally you should have done these already, but then now just to check your answers, let's see. We want to distribute, right? So 2x times 5x, that'll give us 10x squared. 2x times 4 gives us 8x. Negative 3 times 5x gives us negative 15x. And then negative 3 times 4 gives us negative 12. All right, so combining like terms, that gives us negative 7x. And then we just bring down the rest, right? 10x squared minus 12. All right, yeah, that would be our final answer. All right, next, question number 20. All right, so this one looks a little bit different, but same line of thinking, right? We have to distribute this 5x to all three of these. All right, so 5x times x cubed, using our exponent rules, that gives us 5x to the fourth power, right? 5x to the fourth power. Let's see, 5x times negative 5x, that gives us minus 25x squared. And then 5x times 2 gives us 10x. All right, next we have to double distribute this. So we distribute to each of these terms now with that negative 3. So negative 3 times x cubed gives us negative 3x cubed. Negative 3 times negative 5x, that gives us plus 15x, positive 15x. And then lastly, negative 3 times 2 gives us negative 6. All right, so we did all of that. Now we just have to combine like terms. Let's see, 5x to the fourth, there's no other terms with that, with the fourth power. So we just write that term. Let's see, we want to write it in standard form. So we go ahead and we look at 3 has the next highest exponent. So negative 3x squared, x cubed. And then negative 25x squared, right? Our next highest exponent. All right, and then combining these, can combine that term and that term to give us 25x. And then lastly, we still need this negative 6. So minus 6. Ran out of room there. But yeah, that would be our final answer. All right, next, question number 21. So to square something literally means to multiply by itself twice. So x minus 9 multiplied by x minus 9. Our answer is not going to be x squared minus 81, right? We have to multiply this twice. So let's see, we get x squared. X times negative 9 gives us negative 9x. Negative 9 times x gives us negative 9x. And then negative 9 times negative 9 gives us positive 81. So combining like terms, after that we get x squared minus 18x plus 81. All right, question number 22. R plus 7 multiplied by R minus 7. Right, same thing, double distributive property. We get R squared minus 7R. 7 times R, 7 times negative 7. We get plus 7R. And then minus 49. So combining like terms, you guys will see that this cancels out. That becomes a 0. So we get r squared minus 49. And if you guys remember from factoring, it makes sense, right? This is the difference of squares. So yeah, difference of squares, that becomes r plus 7, r minus 7. All right, question number 23. It's a word problem. We're just finding the area. We know area is equal to our length multiplied by the width. Right, so they tell us that our length is x minus 8. And then our width is x minus 4. So multiplying that out, we just get x squared, right? X multiplied by negative 4 gives us negative 4x. Negative 8 times x gives us negative 8x. And then negative 8 times negative 4 gives us positive 32. All right, so x squared minus 12x plus 32. That's our final answer. All right, question number 24. We are factoring. So if you guys remember, a lot of students are always making this mistake. They're not factoring out the greatest common factor, right? The greatest common factor of this would be 3, right? And y, right? They all share a y. So dividing each of these by 3y, that's sort of why we learn about our exponent rules before we learn about factoring, because we need to learn that, well, if we factor out 3y, that means to divide each of those by 3y, and then we use our exponent rules. 12 divided by 4 gives us 4. Y cubed divided by y gives me y to the second power, right? Subtracting those exponents. 3 minus 1 gives me y squared. All right, 33 divided by 3 gives me 11. Y squared divided by y gives me just y. Lastly, 6 divided by 3 is positive 2. And then y divided by y is just 1. So that gives me 2 times 1, which is just 2. So I don't need to write that 1. All right. And that would be my final answer. So maybe some students might think, hey, wait, I thought we could factor out this now. Well, if we think about this, if we want to try to factor that quadratic, we want two numbers that multiply to 8, right? 4 times 2, or 8 times c. And then adds up to 11. So this is not possible, right? We can't find two numbers that adds up to 8, multiplies to 8 and adds up to 11. Yeah, not factorable. Not factorable. Right, so this is our final factored answer. Right, if you guys are getting confused about maybe solving, right now, this is not an equation. All we're doing right now is factoring. Chapter number 9 is when we think about solving, right? If this was equal to 0, that's when we would think about solving for y. But this is not an equation. We're just reviewing how to factor for now. All right, question number 25. So this, we should definitely be comfortable with doing all of these problems. Well, the a is equal to 1. Maybe we might need some review about how to factor when a is not equal to 1. But a is equal to 1. Two numbers that multiply to 10 add up to negative 7. Right, c at the top, b at the bottom. That'll be, let's see, negative 5 and negative 2. Right, so negative 5 multiplied by negative 2 gives us positive 10. And negative 5 plus negative 2 gives me negative 7. All right, so now I can just use that shortcut method, right? Can use my shortcut method. A is equal to 1. So can use shortcut. Right, and that shortcut is, well, our final answer is just going to be something multiplied by something, and that something is x minus 5, because we have that negative 5. And then x minus 2, because we have, why does it keep doing that? X minus 2. Next, 48. So let's see, 48, negative 14, negative 6, and negative 8. Once again, just from doing a bunch of math, I know that, well, yeah, those two numbers would definitely work out without using my factoring chart. But anyways, skipping to our final answer, that'll just be x minus 6 multiplied by x minus 8. Question number 27, negative 18. Two numbers that multiply to negative 18 adds up to 7. So let's see, 2 and 9. Yeah, 2 and 9, that'll work. And then we need to multiply to negative 18. So one of those needs to be a negative, right? And then it has to be that negative 2 because we need a positive 9 plus a negative 2. That'll give me positive 7. That's the only way it'll work. All right, so skipping to our final answer with that shortcut, we get x minus 2 multiplied by x plus 9. All right, question number 29. This is where we can't use our shortcut. We have to go ahead and factor by splitting our middle term. But we do the same process, right? We do the same process where we try to find, let me just do it over here. You guys will see why later. A times c at the top, right? A times c, 3 times negative 2, that gives me negative 6. And then our b term at the bottom, which is just positive 1. All right, so let's see. That'll be 3 and negative 2. So now we have to split the middle term because our a is not equal to 1. So we split that middle term using those two numbers. We could split that x into 3x minus 2x. Right, that 3 and the negative 2, just split those using that. And then we bring down the 3x squared. And then we bring down that negative 2. All right, so here's where we factor by grouping. Right, we factor this, and then we factor that. So the greatest common factor of 3x squared and 3x is 3x. Right, so 3x on the outside. On the inside, dividing this by 3x, we just get an x. Dividing 3x by 3x, well, the same thing divided by the same thing will always just be 1. Next, negative 2x minus 2. So I know that if I factor out a 2, it's not going to work because I'm going to have an x minus or negative x minus 1 on the inside. And remember, we want our parentheses to be the same. So if I factor out a negative 2, that'll make it work, right? Negative 2 and then x plus 1. And if we check, negative 2 times x gives me negative 2x. Negative 2 times 1 gives me negative 2. So yeah, that works. And then now lastly, we have the x plus 1 in common. So x plus 1. And then what else do we have? Well, we have this 3x, and then we have this minus 2. So 3x minus 2. All right, so try to pause this video and try to do number 29 by yourselves by factoring that middle term, splitting that middle term. All right, so here we go. We got 12 at the top, 7 at the bottom. Let's see, 12. Oh, yeah, 4 and 3. I was afraid this wouldn't work, but yeah, 4 and 3. Next, we go ahead and split up our 7x into 4x and 3x. All right, and then let's see, 2x squared, we just bring down. And then that 6 we just bring down. All right, now we factor by grouping. So we factor 2x squared and 4x by itself. The greatest common factor of those is 2x. Yeah, so dividing each of them by 2x. Divide that by 2x, divide that by 2x. So 2x on the outside. On the inside, let's see, 2 divided by 2 is just 1. X squared divided by x gives me x. 4 divided by 2 is 2, positive 2. And then x divided by x, well, that just equals 1. So we don't have to multiply by 1. We don't need that 1. All right, 3x plus 6, our greatest common factor is positive 3. And then 3x, let's see, dividing each of these by 3, we get x, and then plus 2. All right, so our final answer, we have x plus 2 in common. And then what else do they have? 2x plus 3. Final factored form. So remember, if we multiply this out, we should get back to our original answer, or sorry, our original question. All right, 30. This is where we use the difference of squares. Difference of squares. Right, so difference of squares, a squared minus b squared. If we have a difference of squares, right, difference subtraction, that'll be equal to a plus b multiplied by a minus b. Right, so our a and b, that's what we have to figure out. Well, how do we figure out our a? Well, we want to figure out what times what gives me x squared, and that'll just be x. So from here, that tells me my a is equal to x. And then if I split that 49 up, that'll be 7 and 7. So that tells us my b is equal to 7. So literally just replacing it in this format, we get x plus 7, x minus 7. Right, 1 plus 1 minus, x plus 7, x minus 7. All right, question number 31. We want to go ahead and factor this. So we can factor it by factoring by grouping, right? So group these two together, and then we group these two together. All right, so our greatest common factor of just these two terms would be, let's see, they share an x. They share x squared, actually, and they also share a 4, right? 4 goes into 4 and 16. So yeah, factoring out a 4x squared. So 4 divided by 4 gives me just 1. So let's see, sorry, 4x squared on the outside. X cubed divided by x squared gives me just an x. All right, dividing that by 4x squared as well too. Well, negative 16 divided by 4 just gives me negative 4. And then x squared divided by x squared, well, those cancel out. All right, next. Negative 3x divided by, what's our greatest common factor of that? That'd be positive 3. I think positive 3. Positive 3. No, we need to factor out a negative 3. So I need to factor out a negative 3 because I want my inside to be x minus 4. So if we walk through this, you will see that we do get x minus 4 if we factor out negative 3. So negative 3 on the outside. And then negative 3 divided by negative 3 is just 1. So we're just left with that x. Next, 12 divided by negative 3 is negative 4. All right, yeah, so we have x minus 4 in common. And then we just get 4x squared minus 3, right? Whatever else we have on the outside. 4x squared minus 3. And that would be our final factored form. All right, so after we learned about factoring, we went into statistics before we went into our Chapter 9 material, right? So stats, what is the mean test score? All right, so the mean, when we're thinking about the mean, this is just our average. So the mean, to calculate that, we'll add all numbers and then divide by amount of numbers. All right, so if we add all this up, let me just get a calculator real quickly here. We want to add all these up. Let's see, 36 plus 65 plus 65 plus 74 plus 86 plus 88 plus 89 plus 96 plus 98 plus 100. That'll equal 900, or sorry, 797. And then we want to divide by the amount of numbers. So let's see. This is 2, 4, 6, 8, 10. So dividing by 10 gives me 79.7. So the average test score is about a B. All right, so what is the median of test scores? If you guys remember, well, we try to find the middle number. Median is just the middle number. Right, so if to find the middle number of 10 numbers, well, it'll just be 5 to the left, 5 to the right. So if we count 1, 2, 3, 4, 5, 5 to the left, 5 to the right. So we want the middle of 86 and 88. Hopefully you guys can see that that'll be 87, right? In between those two numbers. What is the mode of the test score? So mode is just the number that appears the most. Number that appears the most. All right, so our mode here is just, let's see, what number did appear the most? Oh, 65. Sorry, didn't see that. 65. 65 appears twice. All right, what is the range of the test scores? A lot of vocabulary here. Range of the test scores. This is just our max minus our minimum. Sorry, max minus our min. So our maximum is 100. Our minimum is 36. So our range here is, what would that be, 64. Find the lower quartile of the data. So if you guys remember, to find the quartiles, now it's just taking the median, right? The lower quartile is just the median of the left. Median of the left numbers. That might sound confusing. Median of the left numbers, well, it's just the median of these numbers right here. So the median of 5 numbers, well, that'll just be the middle number right there, right? 65. 2 to the left, 2 to the right. So yeah, that would be our median. So 65. The upper quartile is just, well, it's the same line of thinking, except it's the median of the numbers. Right numbers, sorry. Median of the right numbers. Median of the right numbers. So if we look, there we go. So if we look at this, the median of these numbers right here would just be 96. 96. All right, number 38. It says find the maximum value. So if we're trying to find the maximum value, let's see, maximum value. Oh, highest value. Yep. Well, we already sort of knew that from calculating our range, right? Our maximum is 100. Our minimum is 36. That's kind of strange that they asked us in that order. Maybe they should have asked us this first. Anyways, moving on. Question number 40. Construct a boxing Western plot of the data using the information found above. All right, so we have to start at 36, and then we go up all the way up into 100. So let's just do us a favor and count by, let's see. Let's count by twos. Does twos work? Twos. Let's see. Count by twos, I would need 36. Yeah, let's just count by two, see if it fits. Let's see. Is that a good idea? Yeah, let's just do it. All right, 36. Let's see, count by twos. I'm gonna say 40 here, and then let's just count by twos. And 2, 4, 6, 8, 10 comes 50. 2, 4, 6, 8, 10, 60. 2, 4, 6, 8, 10, 70. Nope, might not work. 2, 4, 6, 8, 10, 80. 2, 4, 6, 8, 10, 90. And then let's just extend this a little bit. 2, 4, 6, 8, 10, 100. Okay, there we go. So if you guys remember using our box and whisker plots to create the box, we draw lines above the median. So let's just take it one step at a time. Our median was from up above, what was it, 87. So we draw a line above 87. That'll be about right there. Then we draw a vertical line above our quartile 1, or lower quartile. That was 65. Let's see, 65 would be about right there. All right, maybe make that a little bigger. Let's see, what else did we have? Our upper quartile was 96, so that'll be about right there. And then now we connect these lines. So let's just try to make it a little bigger. We connect these lines to make our box part. All right, and then the whiskers just come from the minimum, which is 36, and the maximum, which is 100. All right, and then we connect those to make our whiskers. All right, so I know it doesn't ask us, but just an important reminder, this is a important concept to understand. Remember, this is literally our median. So that tells us that 50% of numbers are to the left of this, and to the right of this, and 50% of our numbers are to the left. Once again, I know it doesn't look equal, but if we go back up here, yeah, 50% is to the right of my median, 50% is to the left. So remember, each of these quartiles represents 25%. This is 25%. This is 25%. I guess I should say from here to here is 25%. From here to here is 25%. And then from here to here is also 25%. All right, question number 41. Use the box and whisker plot to answer the following questions. All right, what is the range of the data for class 1? So looking at class 1, well, we see our range is our max minus our min, right? Max minus our min. So our maximum is, well, that's our highest whisker, or the whisker all the way to the right gives us 95. The whisker all the way to the left gives us our minimum. That'll be 30. So the range here is just 65. Yeah, 65. What is the meaning of the data for class 2? Well, as we know, constructing this, we know that our meaning is literally going to be this middle dot. So it'll be 75 just from looking at the graph. What percent of the data for class 2 is greater than 65? So greater than 65, we want all of this right here. All of this. So what percentage? Well, we know that from here to here is 25%. We know from here to here is also another 25%. And we know from here to here is also another 25%. So each of these sections represents 25%. So that tells us that, well, that data is 75%. All right, D, what was the lowest value for class 1? The lowest value, this is literally asking us, well, what is the minimum? What is the minimum of class 1? And as you guys know, our minimum is, well, we did it before, 30. All right. Let's see. Use the table below to answer the following questions. So it looks like they did maybe a survey asking 160 total students in 10th and 11th grade whether they preferred baseball, football, or basketball. All right. So if we're looking at this, how many people prefer football? Right. Football is this column. So how many people total, both 10th and 11th graders? Well, that would be 65. So 65. Let's just assume they said students, or these are students. Yeah, It's a good assumption because 10th and 11th grade. All right, what is the joint relative frequency of 10th graders who prefer football? So joint relative frequency, this is just asking us, that's just a fancy math word of saying percentage. What percentage of 10th graders prefer football? All right, so of 10th graders, that's going to be our total, right? So our total amount of 10th graders, remember it's the part over whole. So as a whole, we're thinking of 10th graders. And then the part of 10th graders, well, we want the part of those 10th graders that prefer football. So out of these 10th graders, right? Out of the 10th graders, so we're going to lower or reduce our table to just that column of 10th graders. So how many total 10th graders do we have? Well, we have 80, right? 80 total 10th graders. And then how many how many enjoy football out of those 80? That'll be 28. All right, so let's see. Simplifying that, our greatest common factor would be 4. Yeah, so 4 goes into 28 7 times. 4 goes into 80 20 times. So 7 over 20. Actually, it's asking us for a percent. Yeah, so let's give that percent. 7 over 20. We don't have to. Let's see. 7 divided by 20. We don't have to. 28 divided by 80. I'm just saying we don't have to reduce this fraction first to get this percentage. So we get 0.35. So 0.35, going from a percent to a decimal, we move it to the left. But now going from a decimal to a percent, we move it to the right twice. Right? So that's 35%. So 35%. Oops, sorry, 35%. All right, what is the marginal relative frequency of people who prefer basketball? Once again, this is just saying the percentage. What percentage of people prefer basketball? So notice they're not saying either 10th or 11th graders, right? They're asking everyone in total. So how many students total do we have here? Well, we just look at that. That 160. So let's say part over our whole or our total. Well, we know the total amount of students is just 160. And what part are we looking for? We're looking for the part that prefer basketball. So out of these students, 36 prefer basketball. All right, so 36 over 160, if we put that into our calculator, that gives me 22.5%. 22.5%, moving that decimal over twice to the right. All right, use the dot plot to answer the following questions. We want to know how many students were surveyed. So literally each dot represents one student. All right, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 students were surveyed. 20 students. All right. Letter B. How many students ran faster than 10.4 seconds? Faster than 10.4 seconds, right? So even when I just thought about this, some of us might think, well, we look to the right? Faster. But remember, faster is less than, right? We want to know how many students ran faster than 10.4 seconds. So it's all of these students, right? 10.3 plus 10.2 plus 10.1. Right, sorry, that's not what we're adding together, but we need to add 1, 2, 3, 4, 5, 6, 7, 8. So yeah, 8 students. And then what percentage of students ran the sprint in 10.3 seconds? So in 10.3 seconds, well, we just look and count. 1, 2, 3, 4. 4 students. Oops. I read that wrong. So that's not our final answer. It's saying what percentage of students ran the sprint in 10.3 seconds. So 4 students, right, part over whole. So we know that 20 students ran a total. And we know our part is going to be 4 students. All right, so that's bad reading comprehension. 4 out of 20. If we put that in our calculator, 4 divided by 20, that'll give me 0.2. So moving that over twice, right, 0.2. Moving our decimal over twice, we get 20. 20.0, but we just say 20. 20%.